my name is Hernandez, Technical Marketing Manager at the Cloud Platforms BU, and I'm going to be talking about CI/CD, GitOps on OpenShift. And I'm going to start off by talking about GitOps specifically, just to kind of demystify what GitOps means in terms of running CI/CD. So anytime I talk about GitOps, I inevitably talk about DevOps only because when I start talking about what GitOps gets you and what that delivers, I always get a kind of sort of pushback from people saying, well, that just sounds like DevOps. That sounds like some things we've already been doing. And that's because GitOps, in essence, isn't really anything different. GitOps is kind of a retooling, right, or a reimagining of what DevOps actually is. And part of DevOps, and one of the major components of DevOps, is CI/CD. And the CI/CD is really still just one of the prominent practices in the DevOps movement. And it essentially focuses on continuously delivering, right, and continuously integrating your application deployments, right? And so you're talking about things like building your application, testing them, doing security tests, releasing that, right, doing that merge. And that's part of the continuous integration, always changing your code, always updating your code. And the continuous delivery part of it is always delivering, or always, anytime you're ready to push into production, you continuously deliver deliver first, right? Deliver fast, deliver often, sort of thing. Fail fast. Do multiple releases a day. That whole Netflix thing of keeping your application continuously delivering. So what does that have to do with GitOps, and what is actually GitOps exactly, right? Like, so you heard me talk about, well, it's not really anything different. There's only a slightly difference between DevOps and GitOps, right? So in GitOps, we take the developer-centric approach to that CI/CD, right, up to and including the infrastructure, right? And so you're taking the things that developers have been doing, and then just for the source code, and then just doing that for the entire platform. So you're talking about things like Git as a single source of truth, right? A Git as you storing everything in terms of not only your applications, but your infrastructure as code, right? So when we say Git as a single source of truth, I'm talking about more like infrastructure as code, where you're keeping, for example, the Kubernetes manifests inside of Git, and you're treating it like as code, right? So kind of the similar workflows that developers have, you're doing that for the infrastructure layer. And so you have things like, in order to scale an application, right, or in order to make a change in the infrastructure, before that used to be like ServiceNow a request. As that goes on, the person, the infrastructure person goes and does that change, either by SSH change. But we're taking that whole process now, we're just dumping that into Git. Whereas if you need a change in the infrastructure, that is done by a PR. I do a pull request, that goes through the review process, and as soon as that merge happens, the change takes place on your platform, on the entire platform. And then, that kind of bleeds over into the operation through Git workflows, right? So they talk about operation. You'll hear a lot talking about GitOps as operations through pull requests. And that's kind of what I was describing before, where you take the approach of your operations now become very developer centric, and not necessarily meaning that the developers are doing it, but kind of the same workflows. And so again, everything that I talked about isn't really that much different, right? People have been doing sort of this kind of workflow, and really where GitOps differs from DevOps, right? So is the fact that there is a reconciliation that happens, right? So if you think about Kubernetes, if you think about how Kubernetes works, right, you got your your desired state, right? To say let's say for example a deployment, you have your desired state. You say I always want 2 replicas running. Then you have your current state, right? What is actually running? And in Kubernetes, the controller, right, for the replica set controller, makes sure that there's always 2 replicas running. So if there's only 1 replica running, it'll look at your current state, it'll look at your desired state, it'll reconcile. Now, take that same idea and just move it up to the entire application, to the entire infrastructure layer, right? Now we're talking about what your source of truth is, or your desired state, which just happens to be in Git this time, instead of Kubernetes, right? Instead of in Kubernetes, we have that in Git. And then you have your current state, what your cluster looks like. And then there's a reconciliation loop, or in this case, what we view as continuous delivery, continuous deployment, is that we look at your desired state and we look at your current state and we automatically reconcile that. And so this is the nuance. This is the slight difference that happens where between GitOps, right, and then traditional DevOps, right. I like to think as GitOps as a cloud-native way of doing CD. Essentially, is you're taking the strengths of Kubernetes and kind of using that in general for your entire cluster. So now, so when you're reading about GitOps and when you're talking about GitOps, just remember that you're really talking a lot about DevOps. This is, except with this little small nuance change where there is a controller sitting on the cluster or your fleet of clusters that is doing the continuous reconciliation. So continuous reconciliation, that is what makes GitOps a little different. And what does GitOps actually get you? So it gives you kind of like a standard workflow that everyone understands really in your environment, right? So if you're working in technology, if you're working on delivering applications, everyone's at least familiar with Git, right? The most familiar people will probably be the developers and the SREs. Even the operation folks know Git, right? So a lot of operations folks have been using DevOps practices, using things like Ansible, storing that in Git. They understand the Git workflows. It's a standard workflow. Everyone can really understand it. I like to group points 2 and 3 together a little bit because you get an enhanced, but that is because you get the visibility and audit capabilities, right? Since everything in GitOps is in Git, right? That's in your source control management system. You have this convenient audit trail now of what has changed in your cluster and by whom and who approved it, right? And the idea is that who approved it? Now that kind of bleeds over into the enhanced security because you can have code review, right? You have protected branches, you have code review, you have all these things in your standard Git workflows that you can use to enhance security. So that way you can even, now we're talking about DevSecOps, you can even have the security guys come and do some of the approval processes as well. So it kind of forces, I think it forces everyone to work together. So, and then you have the consistency, right? So since Git is the source of truth and you have a reconciler somewhere doing that reconciliation loop, you'll have that consistency across, your clusters. And so, so now that we talked about GitOps, just in general, right, from a high-level overview, let's talk about the workflow a little bit, right? And this is, I'm going to be, completely honest. This is a very, very high-level, very simple view of the GitOps workflow, the application delivery model, but I think it illustrates the point very well, right? So you have a source code repository. Actually, this picture here isn't really different, right? So you have the source code. There's some sort of CI process that does, git clone, does a build, does, test, what are all the things that you like about your CI system, and then it pushes that image into a registry, right? So that part kind of stays the same. So what ends up happening as part of, at the tail end of your CI system, you have your config repository. So you have, at a bare minimum, you have 2 repositories. You have one for your application code and one for your configuration code. The reason for that is they'll have different life cycles. Mono repo is what we call it, single repo of it all together. It does work in some circumstances, but I find this is a lot easier and a lot cleaner over the long run in terms of scale. So, anyways, this that besides that point, the CI system, as part of your CI system, it makes a change to your configuration Git repo. Once it makes that change, then you have your standard workflow, and then once that change is merged right into your branch, whichever branch you're tracking, the CD system, right, the reconciler, then either push or pull model, it doesn't matter, ends up on your cluster, right? And so again, very, very big difference between traditional DevOps, traditional what I like to call event-driven, application delivery. The real difference between that and this is this little section here is, again, I like to stress, is the reconciliation that happens here at the CD. And so the CD system is continuously running, monitoring, detecting drift, taking action if it needs to, and then doing a deploy or reconcile if it needs to. So all of this is to say that from a Red Hat perspective, right, from an OpenShift perspective, this is our vision for what CI/CD looks like on OpenShift, right? So CI/CD and GitOps, right? We kind of starting to glom those together because we're vision of doing CI/CD is moving from a more traditional sense to what I like to call a cloud native way of doing CI/CD. So I like to call what OpenShift is doing for CI/CD is a cloud native way of doing. So and this is made up of different parts, right? So I like to kind of take a step back and talk about the different parts that this that makes up the CI/CD, cloud native CI/CD on OpenShift, right? So we have things called OpenShift Builds that is used to build your application. We have OpenShift Pipelines that you probably guys all know and love, and OpenShift GitOps, which we went GA with a couple months ago. So so now taking a look back at that delivery model, we have you can see of where that fits in that delivery model is like we have OpenShift Builds and OpenShift Pipelines doing the CI part, and OpenShift GitOps is doing the CD part. So so let's talk about OpenShift Builds a little bit and kind of look at that as a high level. And so OpenShift Builds, the idea is that you have a single interface to your application builds, right? To turn source code essentially into a container image being able to run. So and the idea is to make that an interface and not necessarily a thing. So then let me explain to you a little bit what that means. Is that essentially you'll take application code and the runtime image and the tool used to build that image, and then you'll end up with an actual running version of your application, right? And what that tool is actually we're going to become sort of agnostic to it, right? So you can continue using source to image, that's fine, but you can also use things like BuildPack or Builda, Canico, or whatever else down the way. We're going to take a sort of less opinionated way of doing things. It's like, well, we'll just give you a common interface in order to continue to use these build tools that that's out there in the ecosystem, right? And so then now you can do things like actually use build packs, right? So you can say, hey, I'm going to use OpenShift Builds. I want to actually the strategy is I'm going to use build packs. Here's my URL, right? And you just provide it the parameters. Or you can stick to source to image. That's fine as well. If you're a big OpenShift user, been using big on S2I. S2I is still staying around. We're now just kind of using an interface into builds. And that's what OpenShift Builds is in a nutshell. It's based on the upstream shipwright. And this will come dev preview in 4.8, 4.9 timeframe. still kind of just trying to get when that's coming out. We'll have an announcement when that comes. Dev preview. Sorry, tech preview. It's in dev preview now. We're talking about. So let's talk about pipelines, right? The next part of the CI/CD vision that of OpenShift. Cloud native CI/CD kind of takes the approach of going away from the monolith, right? And so when I talk about the monolith, like usually someone will have a CI/CD system, right? It'll have things like a central cloud-based server, and we're taking that and we're actually saying, well, that can be like a serverless type of function, whereas well, I don't need the build server to be up all the time. I just need it when I need it, and then the cluster can then reclaim those services as well, right? And so you have like a serverless way of doing pipelining, right? So then this is kind of the kind of different from the traditional CI/CD, whereas and I hate using that word traditional because it's still kind of like a valid way of doing it, but comparing it to cloud native is you do have a lot of tech debt when you're talking about like CI/CD, whereas it's designed for virtual machines. It's like a centralized engine, right, for ops to take care of. It's hard to get native interoperability with Kubernetes resources. I'm sure there's plugins nowadays, but there's really no native way of doing things there. And there is someone just needs to manage it. Whereas at cloud native, we take a service approach where the idea is to have no ops overhead, meaning that the build happens, the container only exists when the build is happening, and if I don't need it, then it goes away in a service-like way. And so we're using OpenShift Pipelines, where it's based on Tekton, the upstream from the CD Foundation, and it's really built for Kubernetes, right? It's thinking about cloud native first, thinking about essentially it's built for building containers, whereas the more traditional way is you're talking about like VMs, APIs, whereas Tekton takes about it's the idea of doing this in a cloud native way. So in OpenShift Pipelines, right, it's been GA for a little bit, and if you've been using it, we have a rich UI, right, where you can actually build Tekton pipelines using the pipeline builder, where you can via the UI add your pipelines, and via kind of like a wizard sort of idea, instead of just dumping your all your YAML into a file and do things via code. You can actually do it via the pipeline builder. And so there's some different here concepts. I may have 1 second, see if my slide advances. Oh, I went too far, I think. There we go. So just general Tekton concepts here, where when we're talking about Tekton and we're talking about the pipelining that Tekton does, is the first concept is a step. When we talk about a step, it's essentially a command run in a container, right? So things like npm install, things like npm install sort of thing. You're running either that or like a shell. You can actually just environment Python and just write a Python script directly. But the end of the day, it's a container that runs something, right? So steps can be chained together. This could be called a task, right? A task is nothing more than a collection of steps, a collection of related steps. So for instance here, this task here is made up of 2 steps. One, to actually build the application. Step 1. Step 2, to push it into the registry, right? The idea of this is that it's actually reusable. right? So you can set up parameters, and it's not specific to your application. It's just you can use this in any pipeline, right? So then you just pass it the parameters it needs in order to build the application. And you don't need to build all the tasks yourself, right? And so there's actually what we call a Tekton hub, right? So it's sort of similar to Ansible Galaxy, for example, where you have all these pre-built tasks that do certain things that are just common that people do. So so you don't have to go and build your own. We load up a preset of tasks. Yeah, it was what we call cluster tasks inside of OpenShift as part of pipelines. And so finally, the last kind of big piece is the actual pipeline. So we talked about steps. Tasks are a collection of steps. Pipeline is a collection of tasks. And so you can do things like run tasks in parallel. You can do them sequentially. You can have conditionals. You can have retries. And essentially, a pipeline similar to a task is that if you have it generic, meaning that like you just have a generic pipeline that can run many different kind of pipeline runs. So pipeline runs instantiation of a pipeline, and essentially it's parameterized, meaning that you can use this over and over. As pipelines from a high level. So let's talk about OpenShift GitOps, right? And OpenShift GitOps is our offering of ArgoCD, and so this kind of gives you a supported way of running your GitOps workflows. And built on ArgoCD is that you have ArgoCD is that agent. So remember when I earlier when I was talking about the reconciliation loop and the reconciler, well, ArgoCD is just that. It's a reconciler. And so it'll track a branch in Git, and it'll make sure that is your source of truth. It'll make sure that your source of truth, your desired state, is always in sync with the current running state. And then you can do things like have granular control over deployment, right? So far, everything we talked about, you can sort of say like, oh, hey, this works for my stateless applications. So what about my stateful application? Well, ArgoCD has that ability to have granular control over sync orders. So you can have certain things sync and wait for other things, right, before it continues on, right? So like to say you want your database up and running before you even bring your front end up, before you even bring in up the router so people can access to it. You could have sort of a sync order for more complex rollout. And since you're tracking in Git, you get everything. It just does whatever it is in Git that you tell it to. So you can roll forward, roll back just by changing the commit, right? You can roll commits forward, roll back, however you do that. And there's a built-in templating system. So whether you're using something like Helm, you can continue using Helm. If you're using, like me, Customize, I love using Customize. If you see all my demos, I use Customize a lot. It's support for Customize. It has others like JSON and things like that. It has native support for those things. And then you can have different deployment strategies. So this is something you get with the OpenShift GitOps operator. You get some of this stuff out of the box where you can have kind of a central hub sort of design where you have like a central Argo system that is used to keep your application in sync across multiple clusters. There's a clustered scope, which is the one that I use, right? Is the one that's most popular. Is essentially you have an Argo per cluster, right? So you have this an ArgoCD system, kind of like a watchdog, keeping your cluster continuously in sync with your Git repo. And then the application scoped, right? So this is kind of like an interesting use case. This is something that you can get out of the box with OpenShift GitOps. With version 1.2, this is even easier. That's coming up in a couple weeks. The application scoped is that you take an ArgoCD, instead of watching the entire cluster, you're watching maybe a handful of resources, like for example, a couple of namespaces. And so you have one application team team A and you have team B taking care of application B on the same cluster, and they may not know about each other. They don't necessarily care that they're on the same cluster. They don't know about each other, and maybe they don't care. And this is kind of the multi-tenant design of ArgoCD and OpenShift GitOps. And part of that is having an opinionated application manager CLI, or what we call a CAM bootstrap. The idea behind this is that it takes you from zero to GitOps. Right? So if you're starting out, you're a developer and you're sitting down for the first time, you say, okay, well, I want to do this GitOps thing. Where do I start? The CAM bootstrap, it'll get you an opinionated way of doing everything I just described, right? CI/CD with cloud native CI/CD with OpenShift GitOps pipelines. The idea here is that this takes, I'm already on the next slide. It takes a while because the animation, there we go. So when you do a CAM bootstrap, essentially it will connect to your Git repo, look at your source code. It'll create another source code for your application developer, for your deployment manifests, and it'll build this whole CI/CD system from the get-go, right? And so that is, right now it's dev preview, tech preview. It'll be out like around the 4.9 timeframe. We're still ironing out a few bugs, but if you want to test this out, it is in dev preview. So by the way, the difference between dev preview and tech preview is there'll be breakage between dev and tech, and there's not a lot of breakage between tech and full GA. And with that, I do believe this will at the end here.